Mindsetters. Welcome to Learn Extra Live. We are on with grade 10 maths with Natasha. Natasha, how are you?
I'm good, Katlego. It's been such a long time since I've been here. It feels like forever, and I hope that everyone's been working
We've
really
missed you,
hard.
and I know the grade 10s and 11s and everyone has missed you a lot. What will we be doing today?
Grade 10s, we're going to start with a lesson on quadrilaterals. We're going to do a quick revision of quadrilaterals and then some tricky questions.
Awesome. I know you guys are excited for the tricky questions part. You guys are such nerds. You love challenges. You love them. Remember that our show is sponsored by Liberty. Thank you, Liberty. You guys rock. Remember that, guys. You can contact us on our Facebook page and our Twitter page. Our Facebook page, for those who don't remember, is facebook.com/learnextra, and our Twitter is @learnextra. Hope you guys have an awesome show. We're going to go to a quick ad break just so you can get your last pens inked and your water and anything you need, and a quick stretch, and we'll be back. Hey, Natasha.
Yes.
See you after the break. Welcome back, guys. I told you to be a very quick break. Remember that we're on with grade 10 maths with Natasha. We are very excited to have her back. We haven't seen her in a while, and I know you guys are excited too. And remember, grade 10s, we have a calculator and a labeler to give away the show to the best mindsetter. Just make sure that you're very active on the page. Ask questions, guys. Ask anything that you need to ask, because we're here to answer your every question. Natasha, over to you.
Thank you so much, Katlego. And grade 10s, welcome to the show. It's great to be back with you. I haven't done a grade 10 session for a while. Today we're going to look at quadrilaterals, which forms part of your geometry section. And I know it's a section that gets everyone a little bit anxious, and people hate the word geometry, but really geometry is such a fun section. I absolutely love it. I think it's one of the best sections in maths. And we're going to start looking at quadrilaterals. What we're going to do, just so you have a heads up, and if you prepare and take notes, you kind of have an idea. We're going to start with a revision of all the different types of quadrilaterals you do, and then we'll probably have a quick break, and then we're just going to go through some questions for the remainder of the show. So if there's anything you don't understand about quadrilaterals, please send your questions through to Katlego on our Facebook page. All right, so let's get started. So some of you might be wondering, well, hopefully I hope that you all know what a quadrilateral is. A quadrilateral is just a closed shape with four sides. Okay, so it's a closed four-sided figure. And you get normal quadrilaterals, which have nothing special about them, but the ones we are interested in is the ones with special properties. So things like parallelograms and rectangles and squares and rhombi or rhombuses, if you like, which isn't correct, but so we're just going to look at all the different types of quadrilaterals with really special properties. But generally, they all have something to do with the palm, except for in the case right at the end, I'll show you where not all the quadrilaterals we will be looking at will be related to the palm. But the first two that we do will all be related to the palm. You hear me saying palm. What is a palm? I'm not talking about the thing in your hand. A palm is the shortened form of a parallelogram. All right. So the first figure we're looking at is a parallelogram. Parallelogram has some certain special features. Okay, and we're just going to go through each of those features. So I've drawn a little yellow diagram there, and I've made some notes on the side. So one of the things that distinguishes a parallelogram from any other normal four-sided figure is the fact that both pairs of opposite sides are parallel. So if you look at this side and this side, they are parallel to each other, the opposite sides. So for example, if I were to call this quad A, B, C, and D, then AB would be parallel to CD, and AC would be parallel to BD. So in a parallelogram, both pairs of opposite sides are parallel. The other thing that's really special about the parallelogram is that the opposite sides are equal. So if you look at your diagram, you'll see side AB has a little stroke on it, and then side CD also has that little line on it. What that means, these little lines, what that means is that those two sides, AB and CD, are equal. And in the same way, if you look at side BD, it's also got two little lines there, and then side AC has two little lines, and that means that AC is equal to BD. All right, so far we know parallelogram things to remember. both pairs of opposite sides are parallel, both pairs of opposite sides are equal. Another property that you need to know is that the opposite angles are equal. So in my drawing there, the opposite angle, so angle A is opposite to angle D. Angle A and angle D would be equal, and then angle B and angle C would be equal. All right, and then finally the diagonals. Remember, a diagonal is drawn from one vertex to the opposite vertex. The diagonals of a parallelogram bisect each other. So what that means, if you look at diagonal AD and BC, this portion is equal to that portion there. So I'm going to put in 3 little lines there. 1, 2, 3. Oopsie, well, that's 1 too many. Okay, let's just get our pen out again. There we go. So that little stroke from B to, if we call that O, B to O, that would be equal to O to C. And then you've got these little portions from A to O equaling to O to D. All right, it's quite a lot of information, quite a lot of stuff that you need to remember. And yes, you do need to know all of this in your head. It's not going to be given to you in a formula sheet or anything like that. You need to know these properties off by heart. All right, so this is just our basic parallelogram. And as I said in the beginning, we're going to develop some of the other quadrilaterals from this. So the next quadrilateral we're going to look at is going to be a rectangle. All right, so let me try and draw this as accurately as I possibly can, given that my drawing is really not that good. All right. Hopefully you all know what a rectangle is and you've seen it before. Okay, and I hope that some of you would already know some of the properties without us saying anything. All right, so if you think about a rectangle, one of the things you should think about is that it is a parallelogram. All right, so a rectangle is a parallelogram, but it's a parallelogram with special properties. Okay, so rectangle is a parallelogram. What that means is it's going to have all those properties that we just discussed with a parallelogram, but the rectangle has some special properties. One of those special properties is that all 4 angles are equal to 90 degrees. So in a rectangle, all of these interior angles, those are all equal to 90 degrees. All right, and then another special property of the rectangle is that if you were to join these diagonals, okay, and as I say, my drawing's not really that accurate, but if you were to draw in your diagonals, the diagonals will be of equal length. So I'm just going to put in some letters here. So if I had A, B, C, and D, then diagonal AC would be equal to diagonal BD. All right. So special properties of a rectangle, all the interior angles are equal to 90 degrees. And the other special thing is that your diagonals are equal to each other. So the entire length of AC is equal to the length BD. Okay, so remember it is a poem, so we're developing things from what we already know. We know the basics of what a parallelogram is, and we're just adding on to that. Okay, so the next one we're going to look at, guys, is going to be the square. All right, so let's have a look at the square. The square is very, very similar to the rectangle, but also some special properties there. And I'm going to try and draw this freehand. Okay, so now we're looking at a square. Okay, and there we go. And a lot of you will remember, I mean, it's one of the first things they teach you when you learn geometry in baby school, is that the 4 sides of a square are all equal. I think everyone learns that right in the beginning when you're like in grade 4 or something. Okay, so special thing about the square, all 4 sides are equal. All right. Another special thing about the square is that it is a rectangle. So it takes all the properties that a rectangle has, and it has those properties, plus it has these additional properties. All right, so a square is a rectangle, but then it has these additional properties, one being that all four sides are equal. All right, and then the other special thing about a square is that the diagonals bisect each other at 90 degrees. So when you put your diagonals in, they don't just bisect each other, they bisect each other at 90 degrees. All right. And then the one thing that I'm going to show you just now when we look at a rhombus, and I haven't discussed a rhombus yet, but a square also has properties of a rhombus, but we're going to get there next. All right. So let's just recap quickly. If you've just tuned in, we've had a look at a parallelogram. Parallelogram has a lot of special properties, and we listed all of the properties of the parallelogram. We then looked at a rectangle. All right, this was a rectangle. And we said that a rectangle was a special parallelogram because it had all those properties of a parallelogram, but it had its little extra bit of specialness, which is that the diagonals were equal to each other. So the diagonals in total length AC and BD were equal to each other. The other special thing about it is that the angles, the interior angles, were all equal to 90 degrees. And then the one we've just looked at now, which is a square, and we said the thing about a square that's really nice is that it is a rectangle, which means it's also a parallelogram. So it has all of those properties. And the special thing about it, all four sides are equal, and the diagonals bisect each other at 90 degrees. Okay, the next one we're going to look at is the rhombus. All right, so the rhombus looks kind of like this, sort of more like a diamond shape, and I made it look a bit strange, but it is sort of like a diamond shape, and we have our diagonals that we put in here. And here, remember, we're looking at the rhombus. Okay. The thing that's special about a rhombus, well, it is a palm, so we know it's going to have all of those special properties. But the other thing is that all four sides are equal. All right. And the two really special properties is that the diagonals bisect the interior opposite angle. So if you look at the diagonals that I've drawn in, what they actually do is they bisect these angles. Okay, so they bisect the interior opposite angles. All right, and the diagonals, just like in a square, they bisect at 90 degrees. Okay, so those are special properties of a rhombus. The diagonals bisect the interior angles. All sides are equal. The diagonals bisect at 90 degrees. What I said to you earlier is that a square is also a rhombus. So a square is a rectangle, or it's a rhombus with some special properties. Remember, in the square, we had the interior angles are always 90 degrees. It's a right-angled figure, okay? And the diagonals also bisect the opposite angles, just like they do with a rhombus. So these two are sorts, the square is the rhombus. A square is a special case of a rhombus, but a rhombus is not a square. Okay, that's important to remember. And a lot of the times your teachers will draw diagrams to show you how one relates to the other. A square is a rhombus, right? It's a special case of a rhombus because each of the interior angles is 90 degrees. But a rhombus is not a square because in a rhombus, it is not necessary for these angles, these interior angles, to be 90 degrees. Okay, so that's important for you to remember. It goes one way, but not the other. All right, there's still quite a few other shapes for us to look at, but those are the ones that all relate to parallelograms. So far we've looked at square, rhombus, rectangle, parallelogram. Those all relate to each other. The next two we're going to look at don't relate specifically to a parallelogram. All right, and the one we're going to look at is a trapezium. That doesn't relate to a parallelogram. We abbreviate trapezium to just a trap. All right, and the kind of shape that you have here looks something like that. Okay. And a trapezium is a special quadrilateral with just one pair of opposite sides parallel. So it's not a parallelogram. Remember that. It's just a quadrilateral with one pair of opposite sides parallel. Okay, so in the drawing, you see what I have, just those two opposite sides are parallel. You get isosceles trapeziums and that, and if we have time, we'll go into that. But in an isosceles trapezium, basically, you have the base angles equal. All right, but it's just a special case. The next figure we're going to look at, that's a special case, that's not directly related to a parallelogram, is a kite. Okay, and obviously everyone knows what a kite is, those things you fly in the wind. Yes, that's what we're talking about, that shape. A kite. All right, and let's just put some of our important things in. All right, so a kite, remember, is not a parallelogram, it's a quadrilateral. With the special thing about it is it has two pairs of adjacent sides equal. All right, so if you look at the diagram that I've drawn for you, these two sides that meet each other and those two sides that meet each other, those are equal to each other. Okay, and those lead to special properties when we put in the diagonals, and if we were to do a question on this, you know, we could draw in diagonal, find all sorts of equal angles and that kind of thing. All right, so just a quick recap: kite and trapezium, not parallelograms. Okay, they are quadrilaterals, they have their own special properties, but they are not parallelograms. The shapes that we were interested in that related to a parallelogram was the square, rectangle, and rhombus. And guys, it's important for you to remember all of this information. You need to go over all of these properties. They won't be given to you. You need to just remember this in your head. And the only way to remember it is by practicing loads and loads of examples, which we're going to do after this break.
Sure. Guys, get your stuff ready. Memorize all your parallelograms and quadrilaterals quickly during the break, because we are going to move on to very exciting stuff. Enjoy your break. Welcome back, Mindsetters. Hope you guys are refreshed and ready to go. Remember, we'll be answering your questions in the last 15 minutes of your show. So send us clear questions and concise questions so Natasha knows exactly how to answer them for you. Remember also that our Facebook page is facebook.com/learnextra and @learnextra for our Twitter page. And we're here to answer your question, guys. So remember, no question is a silly question, because you need to know everything about this. So make sure you ask everything. Natasha, over to you.
Thanks, Katlego. And she's right. If you want to ask questions, please make it clear. You know, sometimes it's very ambiguous and it's difficult to understand what you guys are asking. So please make sure all your questions are as clear as you possibly know how to make them. All right. So the first question we're going to look at are quadrilaterals. We are given a parallelogram ABCD. All right, and remember I said to you we often abbreviate parallelogram to PARM, P-A-R-M. And we are told that AE, which is that line that's drawn, that bisects angle A, and FC bisects angle C. All right, now guys, usually before I even look at the question, what I try to do is I try to write down as much information as possible without even looking at the question, especially since I haven't even written the question down here. You don't know what the question wants. So what I try to do generally is, in geometry, write down all the stuff you can on your drawing just from the information that you have been given. Okay, so let's do that, and let me show you how you would do that. So we are told that ABCD is a parallelogram. Straight away we know some things. We know that that means that AB is parallel to DC. AB is also equal to DC. We also know that BC is parallel to AD. Okay, so we know that the opposite sides are parallel. We also know that the opposite angles, so angle C is equal to angle A, and then angle B is equal to angle D. We know the opposite sides are equal. And then remember all the things you also learned about transversals, and when a line cuts a transversal, those parallel line properties, you get your Venn diagram, your co-interior angles, corresponding angles, alternate angles, all of those special angles that will also apply in this drawing. The other thing we've just got to do is, because they tell us that AE bisects angle A, we can straight away write some angles in. So they've marked off that this angle DAE, that little one in the center there, is Y. All right, so if that's Y, if angle AE bisects, remember what bisects means. Bisect means cuts into equal pieces. So if AE bisects angle A, that means it's cut that angle into two equal pieces. So if that little portion is Y, then the portion right next door to it is also going to be Y. All right. Remember, we also said that FC bisects angle C, or that's what we were given. So that means that if we know what this whole of angle C is, then these two little portions would be equal, because bisects tells me that those two angles are going to be equal. And using our properties of a palm, remember we said that angle A is equal to angle C. So if you look at the whole of angle A, you'll see that it's equal to Y plus Y. So angle A is equal to 2Y. So if angle A is equal to 2Y and A is equal to C, because they're opposite angles of a palm, that means that the whole of angle C must be 2Y. Okay, it makes sense. Opposite angles are equal. A is 2Y, that means that C must be 2Y as well. But remember that angle C was bisected by this line FC. So therefore each little section of angle C, each little section here is going to be Y. All right, I hope all of you guys follow that. That's quite important. Okay, so we use the properties of a palm to help us get that angle C is 2Y, and then in turn each portion of angle C, or each little part of that makes up angle C, is Y and Y. Let's see if there's any other angles we can fill in. Remember from parallel lines, since AB is parallel to DC, if angle A is 2Y, then using co-interior angles, angle D would be 180 minus 2Y. All right, so angle D is 180 minus 2Y using co-interior angles. Similarly, using this side from B to C, if angle C is 2Y, then angle B would be 180 minus 2Y. Or hopefully you guys can also see, using opposite angles, angle B would be equal to 180 minus 2Y, because opposite angles of a palm are equal. All right, the question now. So we've just filled in all the information. We don't even know what the question is. And the question says, write down, okay, so write down all interior angles in terms of, and I'm abbreviating here, in terms of Y. Okay, so we need to look at the diagram and write everything that we see. All of the interior angles, we've got to write them in terms of Y. So let's get going. We know that if I call this one that we were given A1, all right, let's just try and put that in, and then call that little one there A2, and then that's going to be C1 and C2. I know that angle A1 was equal to Y because that's given. So therefore angle A2 will be equal to Y, and that's because we were told that AE bisects angle A. And that's important, guys. If you're going to make a statement, you need to back it up, right? Because you do get marks for that. You need to give a reason for your answer. So I said that angle A2 is equal to Y, and then I've got to say, why do I say that? And I say that because we were told that AE bisects angle A, and since A1 was equal to Y, that means that A2 would also be equal to y. All right? The next interior angle we can find, we know that angle C is equal to 2y. Remember, if you're going to make a statement, give a reason. Angle C is equal to 2y because opposite angles of a palm are equal. Whoopsie. That is an R for those who can't make it out. The opposite angles of a palm are equal, so therefore the whole of angle C is equal to 2y. Therefore, each of them, angle C1 is equal to angle C2 is equal to y, because, let me show you in the diagram what we're talking about. So we're saying angle C1 is equal to angle C2. Those are both equal to y because if C bisects, remember, means cuts in two equal pieces, because FC bisects angle C. Okay. So FC bisects angle C. All right, so far we've got angle A2, we've got angle C. Now we need to find angle B and angle D. And remember, we did this before we even showed any working. We know that angle D is equal to 180 minus 2y. So angle D is 180 minus 2y, and the reason for that was co-interior angles, because if we go back up to the diagram and have a look, we know that AD is parallel, or we can go across this way. AB is parallel to DC, so therefore those two, angle A and angle D, would be co-interior. So we've got AB parallel to DC, AD parallel to BC, which means we're going to get all of those special angles, and that gives us our co-interior angle. So we've got D is 180 minus 2y because of co-interior angles. Remember, your co-interior angles always add up to 180 degrees. All right. Okay, so angle D is equal to 180 minus 2y. Then going back to the diagram, we can say that angle B is also 180 minus 2y, and that's because of opposite angles of a palm. So B is also 180 minus 2y because opposite angles in a palm are equal. All right. We can fill in a whole lot of other angles as well in this drawing, okay, but they just wanted the interior angles, which are the ones at the end, which are A, B, C, and D. So we've written those down. But what we can do is we can also write down angle E, angle F, and just a little, we can make this E1, E2, F1, F2, and let's just see how far we can go with that before we look at the next part of the question. Okay, so I'm just going to, based on what we've got now, just write down, whoopsie, there we go. All right, I'm just making it a little bit clearer for you guys to see. So based on what we've got so far, I'm going to write down E1, E2, and F1 and F2. So I'm going to call this E1, that's going to be E2, and then F1 and F2. And then this we're going to just do it verbally because they didn't really ask this as part of the question. But we can say that angle E1 is equal to Y. And the reason for that, hopefully you can see it's that Z shape. So I've got E1 equal to, let's see where we can write this. We've got E1 equal to, angle E1 is equal to angle A2 Alright, let's try that again. E1 equaling A2. And the reason for that, the Z shape, your transversal, we're talking about alternate angles. Okay, so those are alternate angles. So therefore, angle E1 would be equal to Y. Also, similarly, we can say, looking at this line FC, if this little one here is y, if C1 is y, then F2 is going to be y, also because of alternate angles. All right, so F2 is equal to C1. And then if we needed to, we can say, or maybe some of you can also see this at home, you've got corresponding angles. So we had that C1 is equal to E1. Okay, no, we actually can't use that yet. And in fact, that's a mistake students often make, and I've just made it myself. Remember, you don't know that AE is parallel to FC. So we can't say that C1 is corresponding to E1. And I was about to say that, and in fact I did, just because I saw it in the diagram. But remember, unless you actually proved that AE is parallel to FC, you can't just make a statement that C1 is equal to E1 because it's that F shape, the corresponding angles. It's not going to work. Okay, you've got to have parallel lines in order to make that statement. Okay, so we stopped ourselves just in time there. All right, so the only way we could do that is using that line AB and DC, parallel lines. So we've got alternate angles with A2 and E1, and then F2 and C1, we've got alternate angles there. And then we can, if we needed to, or if we wanted to, we could say F1 is 180 minus y because it's angles on the straight line, and similarly E2 is also 180 minus y because of angles on the straight line. All right, now the next part of the question says prove that, and I'm just going to color this in for you. What would work best? Let's use white. Prove that AFCE, so this portion here, prove that AFCE is a parallelogram. Okay, so you're asked to prove that that shape that I've put white dashes across is a palm. Now, in order to do that, guys, you need to ask yourself, what are the properties of the palm that I can use here to show that this shape is in fact a parallelogram? So remember here, you're looking for either opposite angles are equal. If you can prove that both pairs of opposite angles are equal, then the shape's a parallelogram. If you can prove that both pairs of opposite sides are parallel, the shape is a parallelogram. Or if you can prove that the opposite sides are equal and parallel, then you can prove that it's a parallelogram. So I've gone through just 3 of them, but you can use any one of those to show that it's a parallelogram. Usually we go for the easiest ones. In this case, what I'm going to do is I'm going to show that AF is parallel to EC in the shape AFEC, and I'm going to then prove that AE is parallel to FC, because if AE is parallel to FC and AF is parallel to EC, then both pairs of opposite sides are parallel, which means that this shape is in fact a parallelogram. All right, so hopefully you're all still with me there. So, proving the first one, proving that AF is parallel to EC is actually quite easy, and I'm going to try and fit this in on the side here. Proving that is quite easy because you've already been given that AB is parallel to DC, because that one, ABDC, is a palm. So therefore, since AF and EC are just line segments of those same straight lines, they must also be parallel to each other. So AF is parallel to EC, and that, remember, our reason there was since AB is parallel to DC. Okay, so the reason there is since AB is parallel to DC, and that we've got because ABCD was a palm. Okay, so proving that first pair is easy. The next one is we had to show that AE, this one, is parallel to this one here. So we had to show that AE is parallel to FC. How do we do that? We can use co-interior angles. We can use any kind of thing like that that we know. Or the thing I was going to do by mistake before, we can show corresponding angles, and we've actually already shown it. Because remember, we've proved that A2 is equal to F2. We've done it in all of the working that we've done so far when we were showing which angles were equal to Y. So A2 is equal to F2, And the reasoning for that, you would have had to be following the show from the start of this question. The reason we've got A2 is equal to F2, which is corresponding angles, which means that those lines AE must be parallel to FC. The reason we got that was equal to that, let's just go through it again. We know that F2 is equal to C1, and C1 was equal to Y, so therefore F2 is also equal to Y. And then we showed right at the beginning that A2 was equal to Y because this angle was bisected, so therefore A2 is equal to F2 is equal to Y, so those are corresponding angles, so therefore that line AE is parallel to FC. So now, since we have that AE is parallel to FC and AF is parallel to EC, we can then say that AFEC is a palm because both pairs of opposite sides are parallel. All right. Okay, so it's quite a tricky one, quite a lot we went through here, and you've got to know your properties so well, and this is why I'm saying it's not something where you can just wing it. You actually need to know all of these properties to be able to apply them. All right, so I'm going to quickly go over it again just to show you what we've done. The first thing we did is we were given one angle, A1 is Y. We then had to show what all the other angles were in terms of Y. And we show that using the properties for parallelograms and using the fact of the given information. Okay, so that's how we did the first part. The second part, to prove that AFEC was a palm, all we did there was we proved that AF was parallel to EC, and then AE was parallel to FC. And since both pairs of opposite sides were parallel, that means that was a palm. So sure, that's quite a mouthful there, Kudleho, and I hope that we've got some questions on it, and I'm sure not everyone gets it perfectly, but geometry is loads and loads of practice.
Yes, guys, remember it's loads and loads and loads of practice. It means everyday practice. And during the break, gather all your questions, all your little queries, anything that you're not understanding, and we'll be right back to answer them. See you after the break. Welcome back, guys. I know you guys are ready to go. Remember, facebook.com/learnextra, and our Twitter handle is @learnextra. And guys, today we're giving away the Casio calculator to the luckiest mindset of all time, as well as a labeler is also up for grabs. So remember to send in all your questions, comments, motivational quotes, help each other out, just be there for each other. Natasha, over to you.
Thank you, Kudleho. Guys, welcome back. Now, we're going to carry on with some of the questions that I've got for you, but if you have any questions on this section, remember we're looking specifically at properties of quadrilaterals and application of those properties. We are not doing area of quadrilaterals today. So any questions you have on properties of quadrilaterals, please send those through, and we'll get to that in a little bit. So the next question we've got is, we are told that WXYZ is a rhombus, so hopefully you know what a rhombus is. But if not, the question says, write down 3 special properties of a rhombus and special properties. And this is going to be specifically properties of the rhombus that are not properties of the palm. Okay, so not properties of a palm. Okay, and my writing seems to have gotten more and more untidy as the lesson went on. But anyway, all right, so we're looking for 3 special properties of a rhombus that are not properties of a parallelogram. So we're not looking for your normal, straightforward, opposite sides are parallel, that kind of thing. Okay, first thing that's special about a rhombus, and we did it just at the beginning of the show, so hopefully you guys remember, is that all the sides are equal. Okay, so all sides are equal. So if we had to go back to our drawing, that means WZ is equal to ZY is equal to XY is equal to WX. All right, so all sides are equal. The next important property that is a special property of the rhombus is the diagonals bisect the opposite angles. Alright, so if we go to our drawing, what that means, the diagonal WY would bisect the angle, so therefore that is equal to that, and that's equal to that, and our little dots. Alright, and then XZ will bisect its opposite angles, so you'd get those two equal, and then those two there equal. Alright, so the diagonals bisect the opposite angles. And then lastly, the special thing that's specific to a rhombus and not to a palm is that the diagonals bisect each other at 90 degrees. Alright, so if we go back to our drawing here, you can see we've put that in. The diagonals bisect each other at 90 degrees, so therefore these little portions here are equal to each other and they bisect each other at 90 degrees. So that's properties of a rhombus that are special and specific to this shape. Okay, the parallelogram doesn't share these properties. Alright, and as I said before, and I keep saying it over and over again, you need to know these properties off by heart. Okay, it's not going to be given to you on a magic formula sheet, so you do have to know these off by heart. The next question said, if angle PZY is equal to 30 degrees, alright, calculate angle PWZ. Okay guys, for this one I'm going to do most of the work on the drawing, so follow on the drawing. So we're told that angle PZY is 30 and they want us to calculate PWZ. So P, and I didn't put that point down, P is actually the center point. Okay, and we're told that PZY is 30 degrees. Oopsie, let's write that again. There we go. So that angle there, PZY, is 30 degrees, and we need to find out angle PWZ. So we need to find out what that one is. Okay, so how do we do it? We know that, and as I said, I'm going to do most of the explanation on the drawing, but if this is a test or an exam, or even if it's just your homework, you need to write down step by step how you would work it out and with your reasons. But just for sake of saving time here, I'm not going to write it out step by step. Alright, so PZY is equal to 30. We know that one of the special things of a rhombus, one of the special properties, is that XZ bisects angle Z. So therefore, if this little part, Z1, is 30, then the other part of it, if we call it Z2, that little part is also going to be 30 degrees. And the reason for that, XZ bisects angle Z. Alright? Then we know that angle P is 90 degrees, and the reason that angle P is 90 degrees, the diagonals of a rhombus bisect each other at 90 degrees. Alright, so therefore, angle P is 90 degrees. If you know angle P, which we do know, and you know this angle Z2, then in triangle WPZ, we can work out this angle W, which is the one we want, using angles in a triangle. So therefore, angle PWZ is going to be equal to 180 minus the sum of the angles in that triangle, so minus 30 plus 90 degrees. Alright, and the reason here is just angles in a triangle, so it's going to be 180 minus 120, and 180 minus 120 is 60 degrees. So therefore, the angle that they asked us to find, angle PWZ, is equal to 60 degrees. But guys, please remember, you can't just do this rough working on your drawing and then just write the answer out the way I did it. I went through it step by step, and each time I wrote an angle down, I told you the reason. So if you go through it step by step, you would say angle Z1, or if you want to call it angle WZP, is equal to 30. Your reason being that XZ bisects that angle. Then we said angle P is equal to 90, and we gave the reason for that. The reason for that was that the diagonals of a rhombus bisect each other at 90 degrees. And then we found, finally, angle PWZ using angles of a triangle. All right, so you see it's a build-up, it's a process, and every time you make a statement and you give a reason, you get a mark. All right. Okay, let's look at the next part of the question. Here we are told if WZ side now, if WZ is equal to 30x plus 10 and WX is equal to 2x plus 6 or plus 160, find the length of the sides. So find the length of each side of the rhombus. Alright, so let's have a look. They gave us WZ, and WX, and then they say find the length if you've given these two sides. Now remember, the only thing we know about these two sides is that they are equal. So WZ is equal to WX, and therefore, because they gave you WX and WZ in terms of variables, in terms of X, you're going to be able to make an equation and solve for X just because they've given you enough information to do it. And you know the thing that connects these two sides, WZ and WX, is the fact that they are equal sides because the shape is a rhombus. Okay, so it looks tricky at first, but you see that with the information you've got, it's actually not that difficult to find the length of the sides. All right, so we're going to start by saying WZ is equal to WX, and this is because of equal sides of a rhombus. Okay, so those are equal sides of your rhombus. So therefore, we make them equal to each other. It's an equation. So we've got 30x plus 10 equaling 2x plus 160. All right, so we've got 30x plus 10 equal to, sorry, it wasn't 2x, it was actually, we were given 25x. This was a 25. Okay, so 30x plus 10 equals 25x plus 160, just an equation which you're familiar with by now. Take all your variables to the left hand side, so we get 30x minus 25x is just 5x. And bring the 10 over, 160 minus 10 is 150. So therefore x is equal to 30. But guys, you are not done here. That's not the answer, because remember, we want the length of the side. So therefore, we need to take the x and substitute it back into one of the expressions. So if I put the 30 back into the expression for WZ, I'm going to get 30 times 30 plus 10. So that's going to be 900 plus 10, 900. Okay, so therefore the length of WZ is 910 units. All right, so I'm quickly going to check over with Katlego and see if we've got any quick questions that we can answer.
Yes, I'm checking that for you. See, Charmaine had a question. Please, can you show us or tell us the co-interior angles, corresponding angles, and alternate angles?
Ooh, okay, sure. That's like a whole separate lesson all by itself, and we have covered this before in transversals. I'm quickly going to show it to you just in case a lot of you are lost with that, but we've used it quite a bit in the questions I've done. Those angles arrive, and we love using this, from the fun diagram. You only get those angles when you have parallel lines. All right, So, Charmaine, what do we have? We have parallel lines. If we have parallel lines, we have a fan diagram, which means we get corresponding co-interior and alternate angles. Corresponding angles are equal. Okay, so corresponding angles, these are equal. Co-interior angles, which is the U or the Z shape, those add up to 180 degrees. And then alternate angles, which is your Z or your N shape, alternate angles are equal to each other. All right, so you get these kind of angles only forming when you get transversals, which are just these parallel lines intersecting each other, and then you get these corresponding alternate and co-interior angles. All right, but as I said, that was a lesson we did way back before we started quadrilaterals, so maybe it's time to do a little bit of revision, Charmaine.
So that is. What a quick show, guys. I know you guys also thought that it was extremely fast. We'll see you next week. And remember, thank you to Liberty. You guys totally rock. Guys, remember, learn more, learn extra. Geometry is all about practice, practice, practice. And remember that labeler and that calculator as well. We're still taking in questions and comments and stuff. See you next week, guys. Remember, grade 11s are next with maths. Bye.